We are going to be talking about the seismic design of steel brace frames, and that will focus on the 2010 version of the AISC code and ASCE 7 as well. And a brief overview of what we're going to talk about today. During the first section, we'll talk about the system selection and the limitations, basically the height limitations that come from ASCE 7. And then we'll talk about the AISC seismic provisions, specifically the provisions that apply to all systems. And then after the break, we'll continue with specific requirements for the ordinary concentrically braced frames and special concentrically braced frames. After the second break, we'll continue with special concentrically braced frames by going through an analysis example. The analysis is probably the biggest change as you come into the 2010 version of the specification from the 05 version. We'll then look at buckling-restrained brace frames and eccentrically braced frames to finish up our discussion today. To start with the applicable building code, typically that's IBC or something that closely references or is very similar to IBC, like a state code, the California Building Code or similar. And pretty much those are straight references with some additions, obviously, to the ASCE 7 document, which has the loads for buildings and other structures. In that document, we do have the systems that the seismic force resisting systems and the height limitations and other use limitations of those systems. But that's also where you're going to find your loads, how to determine your earthquake loads and others, and the load combinations that you use for your design. It also has design requirements. In our discussion today, there's no specific design requirements that come from the ASCE 7, but there are specific requirements for the steel system that are not specific to brace frames, so they're not covered in today's session. It also has the requirements for the steel design codes, meaning which codes do you use. The AISC specification, often referred to as AISC 360, especially by me in this presentation. And when I put AISC 360-10, that just means the 2010 version of the AISC specification. That applies to all steel buildings. There is also requirements for the seismic provisions, which is a separate document. That one number is AISC 341. Again, the 2010 version gives you AISC 341-10. Just as a quick side note, the specification, the 2016 version of the specification from AISC, I believe will be released shortly. I know the final public review has gone through. I think everything's just getting finalized there. And the seismic provisions will be a little bit behind that, probably midsummer of 2017 or around there. So it'll be interesting to see the changes there, and at some point we'll perhaps have an opportunity to discuss what's changed in seismic design. We'll start with the building frame systems and limitations table from ASCE 710. That's table 12.2-1, and we do have the systems listed here that we'll talk about today. Starting just in the order there in the book, not the order we're going to discuss them today. There's steel eccentrically braced frames. You can see there's the detailing requirements in 14.1, and really what 14.1 just kind of points you to whether or not the seismic provisions are required. And then we have R factor for each of the systems. Eccentrically braced frames and the steel buckling restrained brace frames, which we'll cover at the end, both have an R equals 8, and that's the highest you can go for these systems. So those are the most ductile, if you will. Followed by a special concentrically braced frames, which does give you an R of 6. There's definitely an advantage to that system over the typical R equals 3 system, which we'll look at in just a second here. For ordinary concentrically braced frames, the R value is 3 1/4, which is basically just a little bit higher than what you would get from a steel system that's not specifically detailed for seismic resistance. And then based on the seismic design category, there are the limits, the height limits for these different systems. And we'll take a closer look at those in the following slides. And I alluded to another seismic force resisting system that is allowed in ASCE 7. And specifically, it's called steel systems not specifically detailed for seismic resistance. And that excludes cantilever column systems because R is actually less than 3 for those systems, even when they are designed using the seismic provisions.